So let me kind of explain where we're going with all of this stuff. Uh, Basically, what's happening is we're tr- we're trying to sort of make sure. Well, our ultimate goal is to learn calculus, and calculus is done on functions. So, in order to um, really work with calculus, we need to make sure that our understanding of functions is pretty strong. So the first class, we basically just looked at some basics of functions, domain, vertical line test. We talked a little bit about piecewise defined functions, being even and odd. Those are kind of considered basic things. Okay. The next thing that we want to study today in section 1.2 is we're going to start looking at different types of functions. So functions can kind of be grouped together in different categories, such as polynomials, rational functions, radical functions, trig functions. These are all things that are important to us. And so I tried to explain this last time, but uh, our strategy will be we learn how to work with little pieces, and then we learn how to join those different pieces together. So these little pieces could be different types of functions that we're working with. Um, but there's one type of function that's especially important, uh, really in mathematics in general, and that's the equation of a line. So you guys have been learning about the equation of a line since forever, probably. Uh, I know we talk about it in algebra, so we got to make sure that you understand all of these details. So that's what we're going to do right now. Okay. So let's take a look at this. Hopefully you can see my screen. We just got to start off with some basics of lines. And whenever someone gives you the slope formula m, I mean, students usually immediately think two words, something over something, right? And what are those two words that people usually say?
Rise over run.
Yeah, rise over run. So I don't know how much I like this. I like the word rise because rise implies this sort of verticality. So rise is really, how much it goes up. We go up. And then the run is really how much we go over. Okay. And this is for a line, this idea of slope it's a proportion. So you can think of it as a proportion. And the proportion remains the same throughout the entire line. So when that proportion remains the same throughout the entire line, we call that a slope, right? And another way that you might have seen this is you might have seen this notation, delta y over delta x. So what does the Greek letter delta mean? What do you think?
Change.
Change is correct. So this is the change in y over a change in x. Okay. So later on, we're going to learn a notation that looks like this, dy dx. This is the notation for a derivative. And when you see this delta y over delta x, and you think to yourself, hey, wait, delta is the Greek letter for d, then maybe this slope is somehow related to this object here that we're going to learn later. This object is called the derivative, and they are very much related. And this dy is related to this delta y, and this dx is related to this delta x. So that's like a little preview for where we're going. Okay. And then if you really wanted to get down to the nitty gritty, you'd have to say, wait, how do I calculate delta y and delta x? And the answer to that is first, we have to be given 2 points. So let's say that we're given 2 points, x1, y1, and x2, y2. Okay. Then the change in y is just going to be y2 minus y1, and the change in x is going to be x2 minus x1. Okay. And I guess the key idea is that, you know, the slope will be the same. For any two distinct points on the line. Do you guys know what the word distinct means? Just means you couldn't choose the same point twice. Okay. So let's pick a couple points. Does anyone have a good point here they want to pick? I mean, to me, I look at this, it looks like the point 9, 5 is sort of right here, right? What's another good point here? 0, 1 looks pretty good, right? 0, 1. So then we could just calculate the slope there. The number one way that students mess up calculating the slope is they switch the order of the points partway through. So if you're really kind of careless about that type of stuff, that you want to explicitly label your points. So you could say, oh, let's have this one be x1, y1, and this one be x2, y2. And then once you label it, you won't mess it up, right? It'll just be 5 minus 1 over 9 minus 0, and then that's going to be equal to 4 over 9. Okay. So what's the meaning of that? The meaning of that is when you go over 9, so here's 0, right? If you go over 9, you're going to go up 4 in order to stay on that line. So we could see that with this particular example. Does that make sense? So our run, our rise, I should say first, I guess. Our rise right here is 4, and our run right here is 9. Okay. All right. I probably talked too long about that because I'm guessing you guys are all experts at lines. But just in case someone was rusty, we need to talk about it in a little bit of detail. Is there any questions or anything? No. Okay. So there are 3 different ways that you can find the equation of a line. So let me move. This up here. Okay. So we're given a slope m and a point x0, y0. When we have this, we can find the equation of the line. So the easiest way to find the equation of the line is to use something called the point slope form. And the point slope form is just, you have this slope, you have this point, you could use those 2 pieces of information to create the line. And the way that we do that is we just have y minus y0 is equal to m times x minus x0. Does that make sense? You know what? I did something weird here. I suddenly wrote these as superscripts on the formula above. Let me fix that. There's a 1 here and a 2 here. Right here, this part I'm talking about. I don't know what happened. Okay. So I don't know if you guys noticed this, but if you just look at this piece right here, doesn't this just look like the slope formula? Right? It looks just like the rise over the run, right? It's like if you just did m is equal to y minus y0 over x minus x0, and then you just multiplied both sides by x minus x0, you get the point slope formula. So it's nothing magical. It's just a modified slope formula. Okay. The other standard form we have for the equation of a line looks like this. It's a slope intercept form. So this is y is equal to mx plus b. And you guys know what m is. M is the slope. But what is this b thing over here? This b thing is called the y-intercept, which is where the graph crosses the y-axis. So can anyone tell me what the equation of the line that we have up above here? What's the equation of this line? Can anyone give me the slope intercept form?
Y equals 4/9x plus 1.
Exactly. How did you know that the y-intercept was 1?
That's where the line crosses the y
Because you can
axis.
just see it on the graph here, right?
Yeah.
Yeah, good, for sure. So the equation, I mean, maybe I should write that. So the equation of this line is y equal to 4/9x plus 1. Okay, so that's sort of like the equation of the line. Okay, and then there's something called standard form. And the way standard form works is it looks like this. It's basically just ax plus by is equal to c. So they just use algebra to manipulate the equation a little bit. And we don't really work with standard form in 5A that much, but I teach math 10 and we write all of our equations in standard form instead of slope intercept form. So that might be more useful for you later. Okay. So let's do a quick example. Let's find the slope here. So we got m is equal to y2 minus y1 over x2 minus x1. I'm going to label my points just because I don't want to mess it up. So I got x1, y1 here, and I got x2, y2 over here like this, right? So then once I've labeled it, it's just easy for me to just copy it. So it'll be -4 minus 5, that's the numerator, and the denominator would be 3 minus -7. Okay. So when you simplify this, you're going to get -9/10. Is there any questions about that? All right. So now that we found the slope, so it's the first thing that we definitely need to find. Then it says find a point slope, slope intercept, and standard form. So we're going to use the slope intercept, the point slope form. So this is y minus y0 is equal to m times x minus x0. So your x0, y0, we got to pick one of these 2 points. I don't care which one I'll pick. Maybe I'll just choose this one, the 3, -4, 1. Okay. So then when we do this, we're going to have y minus -4 is equal to -9/10 x minus 3. And this is the point slope form. Okay. We can manipulate this to get the slope intercept form by doing some algebra. So let's simplify this a little bit. Let's go y plus 4 is equal to -9/10 x plus 27/10. We got to distribute, right? Distribute. And then we can move the 4 to the other side. So we're going to get y is equal to -9/10 x plus 27/10. If I add 4, I'm sorry, if I subtract 4 from both sides, -4 and a -4 over here, that's going to turn out to be -40/10, right? Okay. So then when we simplify this, what do we get? We're going to get hold on a sec, sorry. We're going to get y is equal to -9/10 x minus 13/10. And that's going to be your slope intercept form. This is the way that we usually write the equation of our lines. So that's this guy. Any questions? All right. And then the last thing we're going to do is we're going to try to write it in standard form. So to write in standard form, I simply put all the x's and y's on one side and leave the constant on the other side. So that this means that the standard form is going to be 9 over 10x plus y is equal to negative 13 over 10. Okay. So that's our standard form. Is there any questions about this? No. All right, great.